Hello students, let us start today's session. In today's session, we are going to start studying a new module, which is your module 14. Now, this module is covered in your section B in the new course. It is a topic which is given in the new course. It was not there in your previous course. So, this is a topic in your new syllabus, and basically it is an OR technique. It is an OR technique for decision making. OR technique, or you can say quantitative technique for decision making. Now, which technique we are going to use? You must have not learned this technique in detail in your school level or in your graduation level, not in that much of in detail. The technique is basically business forecasting models we are going to discuss. We are going to forecast various aspects of business. In business, decisions are taken for future. So we have to predict future. So how we are going to predict future? Please understand, we are going to predict future. What is going to happen in business? How much sales are going to happen? Accordingly, we are going to employees, workers, and do the production. So we are going to forecast various aspects of business using statistical tool. Various statistical tools are used to forecast future of business. Various variables, aspects, factors of business we are going to forecast. So the method that primarily we are going to learn is your time series method and regression analysis. First, we are going to pick up regression analysis. First topic that we are going to pick up is regression analysis. So these are the techniques that we are going to focus on, forecasting methods. Basically, you have to understand these are QR techniques, quantitative techniques, and basically we are going to do decision making only, but we need to first forecast what is going to happen in future. Now, just let us do a little bit of theory portion. Theory portion here means just a starting point. Now, forecasting methods can be classified in two forms. It can be classified in two parts. One is quantitative methods and one is qualitative methods. See, again, do not forget what we are doing. Forecasting. Forecasting what? Various aspects of business, various variables like how much sales are going to be taken in future, how much production we are going to do, or how much human resources will be required, or other aspects like raw material, how much raw material will be required. So all these forecasting we have to do because we have to prepare budgets also. So the forecasting, how are you going to do forecasting? The general method is qualitative method, where you do not use figures or data. You do not use data. There is no data available. You just do survey, interviews, or you just do observations, and you take a decision, or you do a forecasting. Just by talking to the other person, you are doing observation. You are doing interviews, you are taking surveys of your customers. So basically the data is unstructured. Okay, this is general way of forecasting. Now let us go to statistical way of doing forecasting. When you put statistical tools, which we are going to teach you, for example, we are going to teach you regression analysis. Now when you are going to put the statistical tool, you will be requiring lot of data regarding these variables which you want to forecast. So you will be dealing with structured data. You will be given structured data which of past. Then statistical analysis you are going to do, experiments you are going to do. Then that type of analysis is called, or method is called, quantitative method of forecasting. Otherwise it is called qualitative. So if MCQ comes and it asks you that when you take surveys or interviews, it is qualitative or quantitative. So you say qualitative. When you take structured data in your observation, when you put formulas, then it is called quantitative method of forecasting. Okay. Now we are primarily going to focus on quantitative method. Now what are the quantitative methods in our course? So quantitative methods that we are going to deal are basically four methods: regression analysis, time series analysis, primarily two methods that we are going to do: exponential smoothing and input output model. These are quantitative methods of forecasting. I have just told you that in quantitative methods of forecasting, we focus on existing data, numbers, formulas. Basically, you use statistical tool. After applying the statistical tool on the data available, you get a conclusive outcome, and then you can take a better course of action. Same thing is written here. There is a very less human interfacing, that is, you do not interact much with you do not take much interviews or observations, just analysis on the data, statistical analysis. Outcome is conclusive, pattern is observed, provide straightforward course of action. Now, this line will be better understood when we start with the first method, regression analysis. Which line? This line. When cause-effect relationship are discovered or suspected, a business can leverage the variable for maximum benefit. This line you will understand better when we will start. Now we are starting with regression analysis. So when you understand what is the method of regression analysis to forecast the variables of future, the variables of business, then you will better understand this line. Okay, so what is regression analysis? Name suggests that it is a very complicated method, but it is not. It is not complicated at all. It is the most simplest method. Suppose, for example, let's say I know that my sales are independent on the advertisement I do. Please listen to this carefully. Okay, let us take an example. We are starting with regression analysis. Okay, suppose I know in my organization sales depend on the amount of marketing advertisement I do. So amount of advertisement I do, marketing I do, it affects my sales. So sale is dependent on marketing variable. How much marketing I will do, accordingly sales are influenced. So the factor which is influenced or dependent is called dependent factor or dependent variable. Sales are dependent on what? Marketing. So this is my independent variable. Okay. Now it is not like that if I do not do marketing, my sales will not take place. Some sales will still take place, but if I do marketing, then sales enhance, it improves. Okay. Now this is the dependent variable. I am giving a symbol Y, and independent variable I am giving a symbol X. This represents X line, this represents Y line, and this is 0. Now if I say this is amount of expenditure, right, on amount of expenditure on marketing, right, and this is sales. Now if I say that if I do not do any marketing, I still have sales of 10 lakh rupees. I still have sales of 10 lakh rupees. But if I do marketing, my sales definitely improves. So if I tell you that if I do, let us write here 2468 lakhs. If I say that if I do sale, if I spend 2 lakh on marketing, my sales goes up to 15 lakh. That is, it increases with 5 lakh. It increases with 5 lakh. Okay. And if I say, see, let me repeat myself again. Suppose if I do not do any sales, if I do not do any marketing, my sales are still 10 lakh. I have put a cross here. When I do a sale of 2 lakh, when I do a marketing of 2 lakh, my sales goes up to 15 lakh. It increases by 5 lakh. So can I say like this? If I do marketing by 2 lakh, my sales increases by 5 lakh. Similarly, if I increase my marketing up to 4 lakh, my sales are going to further increase by 5 lakh. So it goes up to 20 lakh. Similarly, so every 2 lakh rupees of marketing I do, every 2 lakh rupees of marketing I do, 5 lakh rupees of sales are increasing. So if I do 6 lakh rupees of marketing, my sales are going to be 25 lakh. Now if I join this line is coming out to be straight line. This line is termed as linear relationship. Because when you increase your independent variable, that is when you change your independent variable, your dependent variable reacts. Now when there was no amount of marketing, you still had some sale, which is now this is termed as A in our regression analysis. A. Now can anybody predict, please, mathematically, not on the chart, mathematically, can anybody tell that how much sales will take place when I do 8 lakh rupees of marketing? So you will say, ma'am, it's very easy. It will be 30 lakh. How is it 30 lakh? Can you create a mathematical formula for it? Very simple. Every 2 lakh rupees of marketing results in 5 lakh rupees of enhancement of sales. So when there is no marketing, you still have a sales of 10 lakh. So I'm asking, my question is how much sales, that is how much will be my Y variable when amount of expenditure on marketing is 8 lakh. That is when my X variable is 8 lakh, how much will be my Y variable? So very simple, how much will be the sales? Sales, definitely, whether you do marketing or not, your sales are going to be 10 lakh. Plus, every 2 lakh rupees, the sales increases with 5 lakh rupees, right? So can I put like this? For every 2 lakh rupees of expenditure, sales increases by 5 lakh. So can I create a unity relationship that for 1 lakh of expenditure, how much will be sales? 2.5. Now this is termed as B, slope. What this B represents? Please understand, this B represents for every change, for every 1 unit of change in expenditure, how much change will be there in the sales. So I know now if I do 1 lakh of expenditure on marketing, my sales are going to increase by 2.5 lakh. So when I do 8 lakh of marketing, how much will be my sales? So how much it is coming? Yes. So how much it is coming? Very simple, 10 lakh plus 2.5 into 8 lakh. So 10 yes, 2.5 into 8 is 20. So it is coming out to be 30 lakh. So basically your Y is going to be 30 lakh, sales are going to be 30 lakh, which you have mathematically yourself, subconsciously, you have already computed it and marked it on the, you have already marked it here. You can see 30 lakh sales are going to take place when 8 lakh rupees of sales are there. But I want to create a formula out of it. So formula is very simple. See, formula is very simple. Yes. Now I want to know this 30 lakh is what? Let us create a formula. Now this is 30 lakh. How have you arrived? 10 lakh plus 2.5 into 8 lakh, right? Now what is this 30 lakh? This is the sales that will take place. Why? What is this 10 lakh? Let us go back and see what is this 10 lakh. Yes. What is this 10 lakh? 10 lakh is your in the beginning when there was no expenditure, when the expenditure, or I should say when X was 0, how much was Y? This is called A. It is termed as A. This is also called intercept on y-axis. So this 10 lakh is denoted by A. So let me put it here with the symbol. So y is equal to, this is a plus, what is this 2.5? I have just told you 2.5 is the slope, b, slope of linear equation. This equation which you are just drawing is which you are just framing out, it is a linear equation. So here b represents what? Basically b is what? You can say slope, or simply it means that when, please repeat with me, when one unit of your independent variable changes, how much it affects your dependent variable. Again, when how much, let me repeat here, when one unit of your expenditure, 1 lakh of expenditure is being incurred, how much change it brings in your sales. It brings in your sales. How much changes it brings in your y component. Sales was what? Y component, and this is your x component. So 1 unit of change in x brings how much percent change, how much change in y. So very simple. Going back here, just a second. Yes. So 2.5 is, this is your b into, this is your x variable. Y is equal to a plus bx. X means when you are going to spend 8 lakh rupees, how much will be your y variable. Now this equation is called simply regression analysis. That's it. Regression analysis is this much only, my dear students. This much is the regression analysis. This equation, which is linear equation, it creates a straight line. It creates a straight line between the two variables. You can see here there is a straight line. Now it starts with the intercept on y-axis, that is called a point. It goes straight because there is a linear relationship. With every change in x, there is a proportionate change in y. Now going back here, now you very well know what is a. A is the how much will be the y when x is 0. Plus b is how much? What is b? You can say slope also, or you can, it is also called regression coefficient also. It is also termed as regression coefficient. In MCQ it can be asked. Otherwise, very simply, b implies very simply that how, if x is changed by 1 unit, how much change will be there in y. So if x changes by so much, how much will be y? Proportionately. Okay. So this is your regression analysis. Now in the question, when you will study regression analysis, when you are going to do the questions, how this simple regression analysis will become mathematically complicated for you for exam purpose. See, in question, what questions you can get, what type of question will come. Question will say, we know x is an independent variable. So question will say, if independent variable is this much, how much will be y? So you have to determine y, dependent variable. But before putting the figures in this, you will be requiring a and b. So we need to learn the formula of a and b also. So basically question will give you x, it will give you data. From that data, you find out b and a, for which there is a formula also. Here my example was simple, so you could have easily find out how much is b, how much is a, but there is a formula for finding b and a. Once you find out b and a, you put the figures of b, you put the figures of a. X figure is already given because question is asking at how much, at this much value of x, how much will be y. So this is the question you are going to do. So it is very simple concept. Now please let us read. So basically in this regression analysis, you are forecasting y when x is so much. You are forecasting a dependent variable amount when independent variable is this much. Okay. So you can read here. Regression analysis is a study on relationship between two variables. Independent variable and dependent variable. Dependent variable also called explained variable or regressed variable. Independent variable is called regressor variable or explanator variable. It describes the issue or point of interest. It represents the prediction because we are predicting dependent variable. Ma'am, we are getting confused with dependent, independent. No problem. Again, you need to understand that independent variable will be given to you, that how much amount of expenditure we do and then you have to ascertain how much will be the sales at that level of expenditure. Okay, so you have to understand that in this regression analysis line, X will be given to you, that at this much of X level, at 8 lakh levels of expenditure, how much will be sales, that will be asked to you. So dependent variable you are ascertaining and independent variable is given to you, and you are creating a relationship by this equation. Which equation? This equation, that is your called regression analysis or regression equation, regressed equation you can say. So it says like this: dependent variable value changes depending on the value of independent variable. Suppose, for example, weight of a human being is dependent on the height of that person. Very true. More height, more weight. Demand for a particular product is dependent on its price. So one variable is independent and other is dependent variable. Now, in my example, there were two variables. One was your sales and other was your amount of advertisement. Right? Now, sales was dependent. This was dependent variable. Yes or no? And this was independent variable. If in our question there is only one independent variable, then the relationship between y and x is called simple regression. But if in the question you have more than one independent variable, you have other independent variable also, more independent variable, more than one independent variable, then it is called multiple regression. So if your dependent variable depends upon more than one independent variable, how is it possible? Why it will not be possible? Sales just does not depend upon the amount of advertisement. It depends upon many other factors. For example, quality of the production. It depends upon amount spent on production. So samples or any other factors. There are many factors on which sales depend. So if you are studying the relationship of dependent variable dependent variable depends on more than one independent variable, then it is called multiple regression. So question is, multiple regression is in our course? Answer is yes, it is in our course. So study of only two variables at a time is called simple regression. Study of more than two variables, then it is called multiple regression. Two independent variables, this is very important. Then when you are doing simple regression, it is called simple linear regression, that is your SLR. And when you are doing multiple regression, then it is called MLR. Okay, so multiple linear regression. Now so we have understood simple linear regression means when there are only one independent variable. And here in multiple regression, there are more than one independent variable. Okay, so we have understood this part. Now, yes, let us read. SLR is employed when there is one independent variable and estimate. What are we basically predicting? Forecasting dependent variable will be how much when we do changes in independent variable. So an estimate of dependent variable, say y, is made corresponding to given value of independent variable, say x, by placing the relationship between two variables in the form of regression line, which I have just told you. Same thing is written here. Okay, if we develop mathematical expression for this line, the resulting equation of this line is called estimated regression equation, which is this only, which I have just taught you. Y is equal to a plus bx. Now here y is basically estimation or forecast of value of dependent variable, and a is what? The intercept on y line when your x is 0. What is b? You can say b is slope of the regression line, but in simple words, basically what is b? I have mentioned here also. What is b? Basically I have written here, b indicates the amount of change in dependent variable that is, for example, in our example, sales, when there is a per unit change in the independent variable. Okay, now I have already told you that this regression equation can only be used when you know a, b and x. X will be given to you, that at this level of x how much will be y we have to determine, but we need to find out a and b. So first we are going to find b. This is the formula of b, and you have to memorize this formula. Okay, summation of the product of x and y. What is this x and y? There you will be given a data of x and y. X we know independent variable, y we know dependent variable. There will be lots of data given to you of past. You take the product of x and y, summate it, minus n here represents number of observations given to you. X bar is average of x, average of y, x square minus n, then x bar square. So we will be using this formula in our example. Once you have found b, then you put the value of b in this equation and you can find out a. How do you find out a? Y bar minus a minus b x bar. So once you find a and b, you can put in the regression equation, and you can determine y. So let us do one thing, and there is another formula of b also, which is your r, that is correlation coefficient, and then standard deviation of y upon standard deviation of x. So we can directly first of all start with the question. Example. I'm starting with an example. You have to write down this example. This is not given in your CMA module. So you write down this example, and then we are going to practically see how we can use this regression line to forecast y when x independent variable information is given to you. And before writing all this, you have to write down, before starting the question, I'm just enlarging the screen. Kindly write down everything whatever I have just taught you. Then we are going to start with an example and understand SLR, simple linear regression, and then we will move on to multiple linear regression. Okay, so I'm enlarging the screen. Yes, now you have to pause the screen and write it down. I'm scrolling the page. First write the notes, then we will then write the explanation that I have given to you. Pause the screen and write it down. I'm scrolling the page. Yes, quantitative methods of forecasting. I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. First write down the explanation, then write down the practical explanation that I have given to you. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. I'm scrolling the page. I'm scrolling the page. Pause the screen and write it down. Yes, before writing the example, just write this portion also. Yes. Pause the screen and write it down. I'm scrolling the page to right side. Pause the screen and write it down. I'm scrolling the page downwards. Pause the screen and write it down. I'm scrolling the page towards right. This is my regression analysis line. Kindly write it down. Yes. So we have written all whatever I've just taught you. Now let us start with the illustration, an example. Now please observe this example. Now in this example, the question says a manufacturer of optical lenses has following data on the cost per unit of a certain company that makes lenses, and the number of units in each order is given below. Okay, so basically they are saying that how many orders are there in, how many units are there in one order, in each order, and what is the cost. This data is given to you. So we have got data, right? What data we have? These are the order numbers. First is order numbers, only the sequencing. Okay. Then it says number of units. In the first order, number of units are 1. At that time, cost per unit is 58 rupees. In the second order, the number of units were 3 and the cost per unit came out to be 52 per unit cost. In the third order, the number of units that we got in the order were 5. The cost per unit was this much, and similarly it is given like this. So we have data. Now this data is structured data. Now what does question want from us? Question want obtain regression equation on the cost per unit. Okay, so we have to make a regression equation, which is y is equal to a plus bx. We have to fill this equation. Use this equation to estimate the cost of 15 units of lenses. Okay, see, we know very well when there are 12 lenses in an order, cost per unit is 22. When there are 10 lenses in an order, the cost is 37 rupees per lens. Now, I have already told you that in question we forecast dependent variable. So what do we have to forecast? Number of units or the cost? We have to forecast the cost. So cost per unit is the dependent variable which is given a logo, which is given a symbol Y. This is your, here in this example it is cost per unit. This implies that independent variable is going to be independent variable, that means is given to us. How much it is given to us? They are saying find out the cost of 15 lenses. Okay, so that means lens, the symbol is X. This is your number of lens that is given. X is 15 units of lens. So now we have to find out what is the cost per lens when the order has 15 units of lens. Order has come for 15 units of lens, then what will be the cost per unit? So 15 units of lens. Now how are we going to solve this question? So mathematically it is very easy. You just have to memorize the formula of B. You just have to memorize the formula of B, which is just given above. Because we have to put the figure, first we have to find out B, then we have to find out A, then only we can put the value of A plus B. X we know 15 units, then we automatically will find A. So this is very simple. Now we have to do just mathematical calculation. How is B ascertained? Just write the information of X and Y. First we fill the table of X and Y. We have been given, see, we know this is your, we know that this is X now and this is Y, right? So now let me put this figure in a table. Yes, now let me put the table here, X and Y, which is given in the question, in my illustration. 1, 3, 5, 7, 10, 12. These is the values of X. When, let me write like this, when 1, 3, 5, 7, 10 and 12. When the number of lenses in per order were this much, what was the cost per unit? 58, 52, 46, 40, 37 and 22. So let me write the same here also. 58, 52, 46, 40, 37, 22. Let me do the summation also, total also here. Total of these figures, because I have to find the average also of the same. So now simple mathematical calculation, 1 plus 3 plus 5 plus 7 plus 10 plus 12. It comes out to be 38. Then, yes, then next calculation, 58 plus 52 plus 46 plus 40 plus 37 plus 22. So it is 255, right? 255. Simultaneously we know number of observations are how many? 1, 2, 3, 4. Number of observations are 1, 2, 3, 4, 5, 6. 6 observations are there. Now let me find out X bar. X bar will be how much? 38 summation of X upon number of observations. So 38 divided by 6, which is coming out to be 66.33. And what is Y bar? Y bar is summation of Y upon number of observation, which is 255 upon 6, which is coming out to be 42.5. So we have computed X bar and Y bar, which will be used in Y in finding out A, value of A. Now in finding out value of B, what do all I need? Let me write the formula of B. What is the formula of B? Summation of the product of X and Y minus number of observations, X mean of X, Y mean of Y upon X square. So basically first I have to find out X and Y product, X square. Rest all figures are available to me, right? Okay. So let me find out the product of X and Y, and then let me find out X square. Correct? So x and y, 1 into 58, 58, 52 into 3. Yes, 52 into 3, 156. We can start using the memory recall also, but I'll do it straightly. 5 into 46, 230. Then 7 into 40, 280, 370, 22 into 12, 264. Now let me find out the summation of x and y is how much? 58 plus 156 plus 230 plus 280 plus 370 plus 264. So we get 1358. 1358. Now I need x square. Okay. Very simple. 1 square is 1. 3 square is 9. 5 square 25. 49. 100 and 144. Right. Now summation will be how much? 1 plus 9 plus 25 plus 49 plus 100 plus 144. So you get 328 summation of x square. Now you have computed everything. Now what do you have to do? You just have to put the figures. So let me write first the formula of B. B's formula is summation of x and y, product of x and y minus n x bar y bar upon summation of x square minus n x bar square. So we know the summation of product of x and y, how much it is coming? It is 1358. Can you see it? 1358. 1358 minus number of observation are 6 into x bar. X bar is how much? 6.33 into 42.5 upon. Then what is x square summation? We know x square summation. X square summation is 328. Okay. So 328 minus 6 into x bar 6.33. 6.33 square. Now if you solve this equation, you will get the value. Let us first write the numerator value and then denominator value. Yes. So let me first write the value of this. 1358 minus 6 into 6.33 into 42.5. So it is 1614.15. Now minus 1358, 256.15, which is coming out to be minus 256.15 upon minus 6.33 into 6.33 into 6, 240.4134 minus 328 minus 87.58. It is coming minus, but it is positive because I have subtracted 240 minus 328. Otherwise it was 320 minus 240. So this is not minus, this is positive only, 87.58. I hope you are understanding. This is 1358 minus 1614, so it is negative, and here 328 minus 240, it is positive. The answer will come in negative. So it is 256.15 divided by 87.58. So it is coming out to be 2.92. 2.92 minus, this is, you have searched B. Now we have to find out A. What is the formula for A? What is the formula for A? I have already told you what is A. A is the intercept on y line. Basically it implies when your x value is 0, still how much is y. Okay, so formula is y bar minus bx. Okay, so let us put the values here. So y will be x bar, sorry, A is equal to x bar y bar minus bx bar. Now y bar, we know how much it is y bar. Yes, x bar a y your y bar is how much? 42.5 and x bar is 6.33. Okay, so let me put the values here. 42.5 minus b is minus 2.92 into x bar is 6.33. So very simple. Let us calculate this also. So 2.92 into 6.33. So it comes out to be 18.48. 42.5 minus minus becomes plus 82.4836, right? So plus 42.5. So you get 60.98. 60.98 is the value of A. Now I can, with using my linear regression equation, y is equal to A plus bx, using linear equation or regression equation, I can search for the value of y. Y is what will be the cost per unit when my x is 15 lenses in one order. A I know, I have just searched 60.98. B I know it is minus 2.92 into x is 15 lenses, right? Now we have to just find out the multiply it. 2.92 into 15, 43.8. 60.98 minus 43.8. Now 60.98 minus 43.8. So it is 17.18. Rupees 17.18. This is your cost per unit when order consists of 15 lenses. This is how you can forecast the value of dependent variable when independent variable is given to you. You have a structured data information given to you. So this is your simple linear equation, which is very, very simple. So please write down. I am sure you must have found no trouble in solving this equation. Please, I am enlarging the screen, just write it down. Then we will do the question which is given in your CMA module. Pause the screen and write it down. This is the illustration which I have just written here for our better understanding. I am scrolling the page. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. What you have to memorize is the formula of B. You have to memorize the formula of B and A. Y is equal to A plus Bx is a very simple equation which we ourselves have derived. But formula of B and A you must remember. Okay. Now please write down. Pause the screen and write it down. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. Yes, now let us observe the CMA module first question. Now this is given in our book on page number 397, CMA module questions. So let us start with illustration number 1. Now illustration number 1 says, there are two variables that need to be studied: export of raw cotton and import of manufactured goods in India. So there are two variables. This is one variable and this is second variable. One is export of raw cotton and import of manufactured goods in India. Following data set for 7 years is provided. What kind of regression model should be used here? What are the results of this regression? Interpret the model estimators. So we have to here first of all prepare the regression model. What do you mean by preparing regression model? Nothing. It just means y is equal to a plus bx. Since they have not told you that at how much x, how much should be y, they have not asked you such a thing. They haven't asked this thing. They want you to just estimate a and b, put the figures of a and b, and then write the equation. Put the value of a, then put the value of b, and then just write the variable x. Okay, so that is your regression line. Now fill up whenever anybody wants to know that with so much of independent variable value, how much will be the dependent variable value, you can easily forecast. So that is called regression model, where you just put a and b value and just write that much only. So how are we going to solve this question? We have been given a data set of how many years? 7 years. Okay, exports and imports for last 7 years. Now I do not know which is an independent variable here in this example and which is an dependent variable. So we are going to assume here that exports is x and import is y. They have just assumed it. It should have been clearly mentioned which is an independent variable and which is an dependent variable. So I am assuming here that exports is an independent variable and y, imports, is an dependent variable. Now we are going to solve this question. So how we are going to solve this question? Question has already finished. We just have to find out the value of a and b. We just have to find the value of a and b, and then write the equation. So in order to find the value of a and b, we need to write down the values of x. This is x and this is y, and then put the formula of b and a certain b, put the values of b in order to find out value of a. So let us start solving the question. Now I have already made a table. So let us start your illustration number 1. Now we have taken x variable to be exports and we have taken y variable to be imports, right? So now let me write here serial number. I will put the values of x here and y here, which is given in the question. So in the question it is given x value to be 42, 44, 58, 55, 89, 98 and 60. So I am putting the same value here. X value to be 42, 44, 58, 55, 89, 98, 60. And serial number means the number of observations. So there are 7 data set. Then imports are 56, 49, 53, 58, 67, 76 and 58. So let me put here the values of y also. It is given 56, 49, 53, 58, 67, 76, 58. So now I have the values of x and y. Now what do I need in order to find the value of b? The formula of b is, yes, the formula of b is summation xy minus n, then x bar y bar upon summation x square minus n x bar square. And what is the formula of a? A is equal to y bar minus b x bar. Okay, so let us find out b. Now is there, this is only formula available? There is one more formula which is available for b and a. I will tell you, but this is the easy formula. You will be saying, ma'am, this is easy formula. Answer is yes, because you just have to compute x and y and only x square, and then just have to put the figures and do the mathematical calculation only. So let us solve this part. Yes, so xy. Now let me open the calculator. Yes, so xy 42 into 56. 42 into 56 is coming out to be 2352. Then yes, 44 into 49, you get 2156. Then 58 into 53, you get 3074. Then 55 into 58, you get 3190 product. Then 89 into 67, you get 5963. Then 98 into 76, you get 7448. And lastly 60 into 58, you get 3480. And now if you summate this x and y product, how much you will get? 2352 plus 2156 plus 3074 plus 3190 plus 5963 plus 7448 plus 3480. You get 27663. Here also, if you do the summation of x, you get how much? If you add this, it is coming out to be 42 plus 44 plus 58 plus 55 plus 89 plus 98 plus 60. You get 42 plus 44 plus 58 plus 55 plus 89 plus, do not get bored, 98 plus 60. You get 446, and I need the x bar. So how much it will be? 446 divided by number of observations. So it is coming out to be number of observations. When you divide, you get 63.71. This is your summation average of x information. And now mean of y, 56 plus 49 plus 53 plus 58 plus 67 plus 76 plus 58. You get 400, and summation of y is 417. X y bar is summation of y upon number of observation. So 417 divided by 7. You get 59.57. Okay, so we have got the values. Now one value is left, x square, right? So let us search for the same, x square. Now 42 into 42, you get 1764. Then 44 into 44, you get 1936. Then 58 into 58, you get 3364. Then 55 into 55, you get 3025. just mathematical part we are doing. No concept is required as such here. 89 into 89, 7921, 98 into 98, you get 9604, and 60 into 60, you get 3600. Now you just have to do the summation. Now let us do the summation of x square. We have to do the summation of x square. So how much it is coming? 1764 plus 1936 plus 3364 plus 3025 plus 7921 plus 9604 plus 3600. So you get 31214. 31214. Now all values we have written. Now we just have to solve it. Put the values here. So what is the formula? Summation of xy. Summation of xy minus n x bar y bar, then upon, once you solve 2-3 questions, it will be on your tips. Summation x square minus n, then x bar whole square, n x bar whole square. Now summation xy is coming how much? This is your summation. 27663 minus number of observation are 7 into x bar is 63.71 into what is, how much is y bar? 59.57 upon summation of x square 31214 minus 7 into x bar 63.71 whole square. Now we just have to solve this and find the value. Okay, so let us start solving this value. Now 7 into 63.71 into 59.57, you get 26566.43, and here it is 27663. So if I subtract 27663, I get, which is positive because I have subtracted 27663 out of 26566. That is why it is coming negative, otherwise it is positive answer. Upon 31214 minus 7 into 63.71 into 63.71. So it is 28412.74 or 75 you can say, minus 31214. So you get, this is again positive, 20801.25. Now we just have to divide 1096.56 divide 2801.25. You get 0.39, which is exactly the figure which is coming in your book. B is 0.39. Now we just have to find out A. In this case we have already computed B, now A. So how we will compute A? A is equal to y bar minus B x bar. This is the formula for your computation of A. So you can see here I have written here. These are the two formulas. Okay, so y bar minus B x bar. So let me put it here, the values here. Now how much is y bar? Y bar, average of y is 59.57. So 59.57 minus how much is B? 0.39. How much is x bar? 63.71. Can you see it? 63.71. 63.71. So how much is this coming? 0.39 into 63.71. So it is 248469, 59.57 So it is coming 34.723972, you can write. Obviously it's positive. So 34.72 is your value of A, which is coming correct as per your book. Now this is how you have to compute the value of A and B. Now is regression. What was the question originally? Question was, you can see here the question, what kind of regression model should be used here? So we will say, since there are two variables, one is dependent and one is independent, simple linear regression model will be used. What are the results of the regression? Interpret the model estimators. So the result is that this is A and B. Now we can write here y is equal to A plus bx, right? So A is 34.72 plus B is 0.39 bx. So that means here, what does these estimates implies? What does A implies? A here implies intercept on the y line. Yes. What does this A implies? 34.79. I have already told you that A is the intercept on y line when x is 0. So this is 34.72. What does this mean? See, y is your imports and x is your exports, independent variable, right? So even when export is 0, there will be still import of 34.72 crores. This is what it means. Okay, so we are going to write the same. Basically, we are going to write that the y-intercept is the value of A, that is when x is 0, equal to 0, the value of y is 34.72 crores. What does it imply? It indicates that even for no exports, there will be import worth 34.72 crores. This is the meaning of value of A. Now what is the interpretation of value of B? What I have told you about the value of B. Value of B is 0.39. What does it indicate? What does B 0.39 represents? That for every change, 1 unit of change in X will result in 0.39 units of change in your Y, dependent variable. So same thing you are going to write here, that B is equal to 0.39 indicates that 1 unit of change in independent variable will result in dependent variable changing by 0.39 units. Okay, so indicates B is equal to 0.39, the amount of change in Y, that is your imports, per unit change in the value of exports that is X. So these are the interpretation. Okay, and you can also have to write, this was a solution for your B part, right? And for A part you have to write here that in case of two variables, simple linear regression model is to be used. Now I want you to know one more important thing, which is there any other way to compute A and B values? Yes, there is another way to compute. The way we have used is also correct, answer will be same. That is, the way we have used is a more easier way to attempt, but there is another way to compute value of A and B. How do we do? Because we have to use this value in this equation, y is equal to a plus bx, linear regression equation. So how do we find a and b value? So there are two equations. Equation number 1, summation of y is equal to a into n plus b into summation x. And another equation is, equation 2 is summation xy is equal to a into summation x plus b into summation x square. Now if you see here, if you observe here, these are two equations, right? These are two equations, equation 1 and equation 2. Both equations have two way. See, when you will use the data set of 7 years figures, you can easily estimate this figure. We have already estimated this figure from the table. This figure is already estimated, summation of x. This we know is 7, number of observations. Now a and b are only two variables which are unknown. Similarly, we know this figure we have already computed in the above calculation. This figure also we have computed. This figure also we have computed. Again, a and b are two variables. So when we have two variables and we have two equations, then by substitution method or by addition subtraction method, we can use these two equations to find out the value of a and b. So, but I find this little confusing because here above we can use directly the formula of b. We have mentioned the formula directly of b. So instead of using this method, I would appreciate you use the formula. Answer will come the same. Okay. So you better use the formula, this equation formula. Otherwise, in your book, they have solved these two equations, found the value of a and b. So either you can do that ways or this way. Answer will come the same. So kindly write down the answer. I'm enlarging the page. Yes, please write down the solution. Pause the screen and write it down. There will be no problem if you directly use this formula, okay? I'm scrolling the page. Pause the screen and write it down. I'm scrolling the page. I'm scrolling the page. Pause the screen. I'm further scrolling the page. I'm further scrolling the page. I'm further scrolling the page. Okay, so we have learned the concept of simple linear regression, right, in this lecture. Now in the next lecture, this is called SLR. Now in the next lecture, we are going to do multiple linear regression, where independent variable will not be only one variable, there will be more than one variable, two variables. So we are going to do multiple linear regression in the next lecture. So this much for this session, and do practice this concept and have a nice day. Thank you.